Greetings, everybody. Learning as a hobby here. I wanted to post a video on starting on the book that I'm going to do for cryptography. And on Wednesday, which is a couple days from now, I should have section 2.2 for the Taylor book and the exercises up. At least I'm shooting for getting those up on the channel on Wednesday. Like I said, it's a couple days from now. If you're if you're watching this later on in the future, it's already posted. So. Okay, so I mentioned in the last video or the two videos ago that I wanted to start posting some videos on the history of math and also on cryptography, which are some other interests of mine in addition to mathematics and physics. I've read through chapter 1 of the Vanderwarden book. Not to get off topic here, but I will be posting a video about chapter 1 in the Vanderwarden book about algebra and geometry in ancient civilizations relatively soon, maybe on the weekend. I just gotta I want to go through the chapter again in detail and write up my notes about it because it's a large chapter. There's a lot of information in there, good information. It's a really good, well-written book, at least judging from chapter 1. But anyway, I don't want to get off topic here. I want to talk about cryptography in this video. So I had a hard time deciding what book I wanted to start on for cryptography, and I decided that probably the best course of action would be to go all the way at the beginning. Um, Particularly because I don't know a whole lot about cryptography. I know basically I know how to solve monoalphabetic substitution ciphers, if you know what that is. That's the extent of my experience. And also, you know, we did some like RSA stuff when I took number theory, which is something that we'll do later on, and you know, when we get to that topic. But so I'm kind of like I guess a beginner as much as anybody. So I figured a good place, you know, what better place to start than in the beginning. So before I show you the book that I'm going to start going through on the channel, I just wanted to make a recommendation about a couple other books that I was considering going through on the channel to start with. One is a very low-level book that's kind of fun. That it's written, I think, more for children, to you know, which is a good book to get them interested in some applications of mathematics. Written by Martin Gardner, who, if you know anything about Martin Gardner, is well known for his math puzzles and all the books that he wrote on recreational math. So this is his book on code ciphers and secret writing. So he does also include some steganography, like invisible ink and stuff in here. This would be a fun book to, if you have kids, to go through with your kids. You can make like he shows you how to make some, you know, rudimentary invisible ink using household items. So that might be a fun thing to do with your kids. Or if you have, you know, a lazy Sunday and you want to go through some relatively easy cryptographic puzzles, this is a good book to pick up to start with, just to get a sense of, you know, what cryptography is all about. Even if you know absolutely nothing about cryptography, I'd say you probably be able to solve the majority of the problems that he talks about in here. It's a well-written book. It's kind of short, like I said. It is Dover. We all love Dover. It was written by Martin Gardner, and like I said, it's very elementary. So even if you don't know anything about cryptography, this is something that you could start on and get a sense for, like I said, what cryptography is all about. So I recommend that one. This one is, let's see, on the back it says $5.95. So, you know, you can't go wrong for that price. So I recommend this one, but I'm not going to go through this one on the channel because while, like I said, while this is a book on elementary cryptography, like really elementary cryptography, it's a little too elementary for it to be too interesting to do on the channel. So I'm going to skip on this one, but you might want to check this one out yourself, like I said. Um, the next one I wanted to show you is a famous book. It's one of the first um, real sort of real what's the word? Like serious books that were written for a lay audience on cryptanalysis, meaning so cryptology is broken up into um, cryptography and cryptanalysis. Cryptography is, you know, sort of like, you know, how the systems that you have to encrypt messages, and cryptanalysis is the methods that have been developed to crack codes without knowing the keys or the solutions beforehand. So this book was sort of like the first serious attempt at writing a book for a lay audience about cryptanalysis. This is by Helen Fausch Gaines. It's a very famous book. Uh, Virtually any book you pick up on cryptography will recommend in the in the recommended reading will say to check this one out. It was written in 1939, so all of the cryptographic systems that are in here are classical ciphers. So things that were not even state of the art in like the World War I, World War II era. They're more its focus is more on classical cryptography, but it has um, a wide swath of topics that it talks about. Um, so let me see. She talks about substitution ciphers, multi-alphabet ciphers. Um, any other interesting? Does she talk about Playfair? I don't remember, but I went through part. I haven't gone through this entire book, but I went through part of it like a long time ago. Um, and it's a fun book. You could take it, with you and like read it in the cafe while you're drinking some coffee and try and solve some of the exercises. Just to show you, she has exercises at the end of chapters. So things like this. So notice that they're ciphers. Uh, they're hidden messages, right? And you can try, they can be cracked using the methods that she talks about in the chapter proper. And there are solutions to the ciphers at the end. I don't know if she has solutions to all of them. Let me see. If it's not all of them, it's quite a number of them. But the solutions are just like, what the message is. It's not like a detailed solution of how to solve the ciphers. It just tells you what the message is so you can check, to see if, although if you get it, if you get it something that makes sense, then obviously you probably have the right key. But anyway, I just wanted to mention this because it's a famous book. And this is also put out by Dover, so this might be an interesting one to pick up too. This one says $12.95. So again, this is a decent price for a good book on elementary cryptography. It's titled Cryptanalysis: A Study of Ciphers and Their Solution by Helen Fausch Gaines. I'm not going to go through this one though, and the reason for that I decided against going through this one is because while she does go through a lot of the different classical ciphers. The focus is not really on the mathematics behind it. So I wanted to I wanted to focus on something where you learn a little bit of math along the way. So let me get to the book that I am going to go through. And this is just the first book on cryptography I want to go through because there's several books that I want to look at. But this is the one that we're going to start with. It's a relatively short book. This is the title: Elementary Cryptanalysis, a Mathematical Approach. And this is by, actually, there's two authors. Abraham Sinkov is the original author, and then it was revised by, what's his name, Todd Fiel. And there's a preface in the book by both Sinkov and Fiel. So I'll read you both of those things because they both contain important information about this volume. This is also a book put out by the MAA, Mathematics Association of America. So I thought it would be good to go through something like this just so you can see like the type of books that the MAA puts out, because I have talked about the MAA press in previous videos. um I like them because they're sort of like good for project books or like independent study. And so this is one of one of the books in the MAA library. And I think it would make a good independent study, or just a summer project or something for someone. This would be a fun one. And we're going to go through it on the channel, so you'll see. So you can see that it's not that thick. So I'm hoping that we'll be able to finish this one by the end of the summer, and maybe go on to a more advanced book on cryptography. So anyway, enough of my talking. Let me actually read through the intro by Abraham Sinkov and Todd Field, so you can get a sense of what the book is trying to do. And then I'll go through very briefly part of chapter one. We're just going to do just because I don't want this video to be long, we're going to do section 1.1 and the solutions to the exercises there. So let me start by reading the preface to the first edition. So this is the preface by the original authors, Sinkov. So here, this is him talking. To a very great extent, mankind owes its progress to the ability to communicate. And a key aspect in this ability is the capability of communicating in writing. From the earliest days of writing, there have been occasions when individuals have desired to limit their information to a restricted group of people. They had secrets they wanted to keep. To this end, such individuals developed ideas by means of which their communications could be made unintelligible to those who had not been provided with the special information needed for decipherment. The general techniques used to accomplish such a purpose, i.e., the hiding of the meaning of messages, constitute the study known as cryptography. Before the development of postal systems and electrical transmission of information, the usual manner of sending a communication was by private messenger. Even under these circumstances, the use of the concealment tactics of cryptography was often advisable because of the possibility that the messenger might be apprehended or prove disloyal. In recent times, a message transmitted by radio could be copied by anyone having appropriate equipment and listening to the right frequency at the right time. In such a case, a sender desiring privacy of communication would be required to employ some method of cryptographic concealment. Now, just as the sender of the message attempted to conceal information from any but the desired recipient, there would be individuals very much interested in determining what the message said, most probably the very individuals from whom the sender was trying to keep the information. Should such individuals obtain in one way or another a copy of the cryptographed message, they would attempt to unravel the secret it carried. But of course, their attempt would have to have would have sorry, of course, their attempt would have to be made without a knowledge of the cryptographic details employed to hide the content. Efforts aimed at reading a secret message in this way come under the heading of the study called cryptanalysis. History abounds with accounts of situations where successful cryptanalysis proved a most important element in achieving diplomatic success. Gaining military victories, apprehending criminals, preventing espionage. Cryptanalysis has contributed to the translation of historical documents, which came to light in official archives and were found to be in secret language. It has even aided in the reconstruction of lost languages, which had been dead for so long that nothing was known about them, so that they were, in effect, secret languages. These aspects of the history and drama of cryptanalysis are adequately treated in many other sources and are not discussed in this book. The purpose of this monograph is to introduce the reader to some of the basic techniques of cryptanalysis. The method used is to describe a cryptographic procedure and then to examine how its details can possibly be reconstructed without any information about them. The appreciation of what can be accomplished analytically may then suggest methods of improving the cryptography by eliminating the deficiencies exploited in the cryptanalysis. Such improvement then poses a new problem for the analyst. This step-by-step improvement has in fact been the history of the development of cryptology. The word used generically to embrace both cryptography and cryptanalysis. The analytical processes used by a cryptanalyst require a number of techniques, some mathematical, some linguistic, some of an engineering character, and even some not readily describable, such as luck, flair, sixth sense, etc. Since this book is being written essentially for students of mathematics, the presentation will emphasize mathematical aspects of cryptanalysis. Some of the other aspects will naturally enter into the general discussion, but for the most part, the emphasis will be on mathematical features. And since the mathematical concepts introduced relate to branches of mathematics not usually studied in high school, they will be treated in some detail as they are introduced. It is to be appreciated that the emphasis on mathematical procedures has resulted in the omission of some other topics. For example, nothing is said about codes, which are dictionary type books used to convert plain language into secret language. The descriptions of methods of solution will be provided by applications to specific examples. These have been selected in such a way as to simplify the exposition. The texts have the texts have been taken almost entirely from newspaper articles. They have been chosen of sufficient length so that the difficulty of solution would not be excessive. No attempt has been made to modify the language or the frequency of any of the letters. As the title implies, the cryptographic systems studied in this book are elementary. They have been well known and used for a long time. The methods of solution have also been well known. Although their presentation has not usually been in mathematical terms, the reader will become aware that the cryptography studied here can be made more sophisticated. Ideas on improving the systems described are certain to come to mind. The most significant types of recent advances have come with the introduction of machines, electromechanical and electronic, and have given cryptographic systems a much more complicated character. Methods for solution of such systems must be correspondingly more advanced. All that we can hope to accomplish in this book is to provide some of the fundamental techniques which are the basis of cryptanalytic endeavor. It is important that readers understand each step in the reasoning presented and that they confirm what is done in the text by studying it in detail if they wish to achieve the kind of skill needed to deal independently with cryptanalytic problems. I should acknowledge here my thanks to, and then there's thanks here for by the author, so I'll skip that. So that's preface by the author Abraham Sinkov. I should also mention here this book was excuse me, this book was written in the 70s, so actually pre-RSA. So the techniques in here are genuinely classical. We're just going to deal with classical types of ciphers, no public key cryptography or anything like that. So, although actually, I think there is a chapter that was added on public key cryptography by the person who did the revision. So I'll read his preface here, and I'll explain. So this is by the guy who revised and updated the book. His name is Todd Fiel. So here's his preface. It's been over 40 years since Abraham Sinkov wrote this wonderful little book. As he mentions in his introduction, preface to the first edition above, this is a book concerning elementary cryptographic systems. Much has happened in the cryptographic world since this book first appeared. Notably, public key systems have changed the landscape entirely. In bringing this book up to date, I have included the RSA method, Chapter 6, reasoning that understanding its underpinnings requires relatively elementary number theory, and so would be a useful addition. The difficulty in breaking RSA leads to the question of what is a perfectly secure system, and so I've also added a chapter on one-time pads. Otherwise, I've tried to change very little in the original text. Some terminology I've brought up to date, direct standard alphabets and ciphers are now additive, decimated is now multiplicative. Sinkov's original exercises I've left unaltered. Their subjects are rather dated, reflecting the Cold War era. There are references to nuclear testing and communists, but leaving them, I think, does no harm to the material being studied and might be now thought of as quaint in any quaint. In any case, decrypting them presents the same challenge as if more modern messages were used. It's hard to find it's hard to find discussion of some of these topics anymore. Methods you can think of as paper and pencil methods. Sinkov still presents the best discussion available on how to break columnar ciphers of unequal length, I feel. He also deals with attacks on polyalphabetic ciphers with mixed alphabets. These and other topics have been usurped by the more modern methods and so have perhaps lost some of their relevance, but they still present excellent examples of how a little mathematics can give you a great deal of insight into the solution of a problem. They also are a source of darn good puzzles. Much of the work needed to break these ciphers falls into the drudge category. Today, this can be done using computers. I have written a program that relieves much of this drudgery called Code Help. It is available at my website. I'll put a link to the website in the description bar below if you want to check out the code that he has for that program. It's written in Java. I haven't looked at it yet, so I can't tell you, anything about it, but I will put the link down below. This program is made available as freeware and is written in Java, and so will run on most platforms. I would appreciate a notification of bugs you find in the program or suggestions you have. These should be sent to, and then he gives his email. It is hoped that by relieving the need for this time-consuming work, more students will be encouraged to delve deeper into this fascinating subject. I've used portions of this text and code help in a course titled Cryptology and Number Theory. I've taught many times at Denison University. This course is for the general population, not mathematics majors. The number theory topics from chapter 6 are grasped even by the least mathematically sophisticated. I'm indebted to my students whose comments have helped me greatly improve code help and the material added in this text. And then the rest is just thanks by Todd Field. He wrote this preface in 2009, and I believe the most recent version of Code Help was updated in 2014. Like I said, I haven't actually looked at it yet, so I can't say anything about the program, but I will put a link to it down in the description bar. So this is the book I want to go through, and just so the video is not too long, I will go through just section 1.1, which is very short and deals with probably the simplest type of cipher that you could possibly have. It involves a cipher that you might even have been aware of in childhood. It's called the Caesar cipher. So let me actually bring up my notes and we'll take a look at that. All right, so this is section 1.1 on the Caesar cipher. All right, the Caesar cipher is a particular monoalphabetic substitution cipher that uses an additive alphabet. So let me just parse that sentence there. So first of all, it's called the Caesar cipher because supposedly Julius Caesar actually used this in his military communications back in ancient Rome. Back then, you'll see when we talk about it, it's a very simple cipher. It's not secure in really any sense of the word, other than back in the times when he was using it, most people were illiterate, so and probably couldn't do too much mathematics, so it was probably more secure back then than it is now. But well, I should say it's not secure at all right now, but in modern times. But anyway, it's a mono alphabetic substitution cipher, meaning one alphabet. So you have one cipher alphabet that you're using to replace the original letters in the original message. That's the substitution part, and it uses an additive alphabet. I'll explain the additive part when we actually get to the procedure. So let me scroll down and I'll explain how you encipher using the Caesar cipher. All right, so here's the procedure. So first thing you do is you write down your message. So you write down the plain text. And I think I have an example down here. So he gives this example in the book. So for example, say you want to send someone this message in secret. I came, I saw, I conquered. So that's called the plain text. That's the message that you want to send. All right, so the first thing you do is you write it down in plain text. Step number 2, below each letter, write the corresponding number from 1 to 26 for that letter starting with A equals 1 and ending with Z equals 26. Now, of course, Julius Caesar didn't use the English alphabet, but it's the same idea. He used the Roman alphabet, but you get the idea. So anyway, so there's 26 letters in the English alphabet. So A is 1, B is 2, and so on, all the way up to Z, which is 26. Then what you do, here's the additive part. This is why it's called an additive substitution cipher. You add 3, specifically for a Caesar cipher, you add 3 to the numbers, calculated modulo 26. What that means is, so if you add 3 to 26, we're only considering numbers from 1 to 26. So if you, for example, add 1 to 26, instead of going to 27, you swing back around to 1. And same thing for, if you get 28, you swing around to 2. If you get 29, you swing around to 3. This way, it's sort of like cyclic like that. That's what we mean modulo 26. In other words, you're doing this using only the remainders when you divide upon division by 26. All right, so add 3 calculated modulo 26 from each number. Step number 4, replace the new numbers with the letters they correspond to get the cipher alphabet, and then replace the letters in the plain text with the corresponding ciphertext. Okay, so let's do a simple example so you can see how that works. All right, so here, what I'm doing first is I'm writing actually down the letters of the English alphabet. So notice I have A through Z, and then I'm labeling them with the numbers 1 to 26. And then to apply the Caesar cipher, you add 3 modulo 26 to each of the numbers. So 1 plus 3 becomes 4, 2 plus 3 becomes 5, 3 plus 3 becomes 6, and so on and so on. And notice when you get to 24, when you add um, when you add 3 to 24, you get back to 1. When you get to 25, and so on, like I talked about before. So and then just replacing back with the letters associated to those numbers. 4 is the English letter D, 5 is the English letter E, and so on. All right, so now instead of actually doing this to the letters in the plain text, you can just use this as a sort of reference to write down what the ciphertext letters are. All right, so for example, let me get a pen out so you can see how this is done. So for example, I becomes L, right? So that's why I have an L down here. C becomes F, and so on like that. You just replace all the letters with their corresponding cipher alphabet equivalent, right? And when you do that, you end up with the ciphertext, which is this thing. Okay, which if you don't know the Caesar cipher, then looks confusing, at least at first, right? Now this is a very weak cipher. Like I said, it's probably the simplest cipher that there is, other than maybe just shifting by 1. But people, even when you're a kid, you might have done things like this. So there's glaring weaknesses in this type of cipher. It's very easy to crack, but at least you get the idea of like what a substitution cipher looks like. All right, so if you want to decipher a ciphertext written in the Caesar cipher, you look up the ciphertext letter in the cipher alphabet and replace it with the corresponding plain text letter. So just so you can see what I mean, if you got in the mail, so say you got the ciphertext that we have down here in the mail, if you want to figure out what the original message was, you would go to L in the cipher alphabet, and you would look up what the plain text letter would be. So that would be I. Then you'd look up F in the cipher alphabet, and that is equivalent to C, right? And so on like that. And if you do that for all the letters, you'll come back with the plain text, I came, I saw, I conquered. Right, so that's how you would decipher the code using the key. Okay, and like I said, although this was an actual crypto system used in history by Julius Caesar himself, although he didn't use the English alphabet, it has many hopefully glaring defects that you can see. All right, so that's basically section 1.1. Like I said, it just talks about the Caesar cipher. It's very short. I want to go over now, because there's only 2 problems in the exercise set for section 1.1. So rather than make a separate video about it, that'll be like a minute long. I think I'll just go over the exercises here as well. So let me bring up the exercise set here. These are the exercises for section 1.1. There's only 2 questions, and so here the questions are: decipher the following messages which were enciphered by means of the Caesar cipher. So here we have 2 messages, and they were enciphered using the Caesar cipher. So to decipher them, all you do is undo the Caesar cipher. So looking at that alphabet, whoops, going back here, looking at the cipher alphabet here, we can decrypt these 2 messages. And if you want to try it yourself, I'll leave this up on the screen for a minute. You can pause the screen, copy it down, and see if you can decipher it yourself. All right, so I'll give you just a second to do that, and then I'll go to the solutions. Okay, so scrolling down. So if you want to decipher, you just take the ciphertext letter and you subtract 3 modulo 26, and that gives you the solution. That gives you the plain text letter. Or you could just, like I said, write down the plain text alphabet and the ciphertext alphabet underneath it, and then just use those to decrypt. Right. So the first message decrypts to this when undo the encryption. Cowards die many times before their deaths. Okay, and then number 2, like I said, it's very straightforward because there's only one thing that you have to do for the Caesar cipher. It's not hard at all to break, or to decipher. All right, so problem number 2, again, same process, just undo the Caesar cipher, and you get that the message decrypts to the evil that men do lives after them. All right, and that's section 1.1. There's, like I said, there's only those 2 problems there. But we'll get to the section 1.2 talks about modular arithmetic, so that'll be a slightly more interesting section. So we'll do that in the next video in this series. But I didn't want to make this video too long, so just so you know, that's the book that we're going to go through first in the cryptanalysis or cryptology stuff that we're going to do on the channel. So pick up this book if you want to follow along with me, and look out on Wednesday for the videos on Taylor. Will do section 2.2. I'm going to try to get both of the videos for section 2.2 up by Wednesday. All right, guys, I'll see you in the next video. Until that time, keep learning and enjoy enjoy your day.